This is what I'm currently working on. Precision analog power supply with remote sensing on it. Constant current, constant voltage. All analog. All designed by me. You can hear the relays. Yeah, one relay is open because I had an issue. I wanted to look at the arcing between the contacts in it. This one only goes down to 0.6 of a volt, but yeah. This is my probing technique. I modified a few probes actually. I'll show you what I do. To get up nice and close. And get rid of some of that tip capacitance also. Really good, I find, for taking noise measurements. And no, this power supply is not actually normally that noisy. I've got some problems down the bottom end with noise, and at the top end you can see I've just turned it up to 4 volts, and if you look at the RMS and peak to peak, it's already dropping down to the microvolts region. Or the peak to peak, still up there a bit. I've got some things to iron out. I had some noise coming from this little power supply I was using just to cool a rectifier and run the thermal control for this fan. Oh yeah, it was going to run the panel meters, but the panel meters that I got from Jaycar were not high enough in accuracy, or digits. So I've ordered some online that are way better in accuracy. Yeah. Anyways, there's my record. Because I have been taking notes. Yeah, I'm still working on another small switch mode power supply, little flyback, and the constant current circuitry. This has all got to go onto PCB and get fit into there too. It's quite a big project. On 2 volts peak to peak, 350 microvolts RMS. I did get better than that. I've had some problems with my power supplies and things leaking noise in. I actually had to create this little boost converter down here with some really good filtering to provide some common mode isolation to this little reference board here, which actually controls the voltage. And yeah. This transistor is going to be thermally compensated. I've actually got a little resistor sandwiched up with some thermal compound and some heat shrink against the transistor in there. It's a BC550. That's going to be thermally compensated because that's the only component in this entire build that isn't thermally compensated. You can see it's very stable. The voltage just stays exactly where you put it. I can put a load on it and show you the load if you want. It doesn't drop at all. It's amazing. It's amazing what you can do with transistors. I am going to be using op amps for the constant current circuitry, but for the constant voltage circuitry, I'm not at the moment. This is my little soldering setup. Yeah. A lot of my stuff's turned off at the moment. I'm building a curve tracer too. I haven't done too much work on this project for a while. I need to get back into it. is actually designed to supply some decent voltage and current to the device under test, like a proper curve tracer, not like the little Chinese kits online. And yeah, basically it's going to have screens to monitor collector voltage, emitter voltage, current, all that sort of stuff. I'll give you a quick look at my component collection. It's pretty big. Been collecting for a long time. Yeah, and then just a little bit of more stock. More projects. Yeah, so that's my lab at the moment. And as you can see, the thing it's missing is some accuracy. This meter's failed, there's no batteries in it anyway, but I bought this from the AEV blog store. It did work when I got it, it was great, but then it failed. So now I'm back to using the Fluke, and yeah, that's only 4 digits. I thought it might have been 4.5, it's only 4. I've only got these other crappy little meters. So yeah, really need some more accuracy. And the way funds are going at the moment these days, I'm trying to save up to buy components still. So it doesn't look like I'm going to be buying a new meter anytime soon, even though I desperately need it. My boards that I save up for salvaging components off of. Anyways, quick look at my workshop. You might want to have a quick look at my dim bulb testing unit too. It's got 2 receptacles on it, some banana jacks, and neon across them for indication. It's got a bypass switch and a main switch, and then each one of these bulbs has got its own individual switch to be switched in line to it, and they're 25 watt bulbs. So if you have a good look, there's 8 bulbs, 25 watts each. I've got 200 watts I can switch up to. It's pretty good in 25 watt increments. Actually, I can show you that now if you want. There you go. If I put a load on my supply, that will glow more. Turn the supply off and on, and it'll cause some funny stuff to happen with a 25 watt limit on it. The flyback probably won't want to start. Might make the bulb do some funny things. Let's have a look. Yeah. Huh? Not really. Oh well. Anyway, that's my dim bulb set up. This is just a little load bank I built for testing out amplifiers. I can introduce different loads, fixed and variable loads into it, run a signal into it, and scope the output whilst it's loaded. So this isn't for output stages, this is for intermediate stages, but I found it's coming very handy for building amplifiers and testing gain and distortion and stuff from different stages in the circuit. Yeah. One of my cats.